Okay, so should I go ask Steve? No. I'm just waiting for her to calm down. Okay, so multiplying binomials using FOIL. Basically, so this is this is the stuff that I get excited about. I mean, this is factoring, and it's factoring, it's multiplying binomials, it's dealing with what are called quadratics. So we're moving into the parabola realm of Algebra 1. And the parabola realm is usually the area most kids don't learn well, because it's always at the end of the year, right? That they're usually people take this in high school, they'll take this class in 1 year. They'll take all of Algebra 1. Algebra 1 is a 1,000-page textbook. And there is, I maintain that most kids cannot learn 1,000 pages easily in a year and really know the material. I think we cram too much in people's brains, and then they never have a chance to learn it and use it, and so that they can actually master it. They just they're exposed to it, but then they forget it because you don't have time to keep doing it, so you move on to something totally different. So this is one of the areas that I like to specialize in with you guys, so that you don't know it poorly, but you actually know it really, really strongly. When you get to high school and you have other kids, you know, in your classes, they're going to be lost, and you're going to say, oh, this is easy, I know how to do this, and then you're going to be able to show them, right? So there's different parts. I'm going to basically be giving you lots of tools to use in these processes, you know, and one of them that's foundational to the whole concept of parabolas and multiplying and dividing and factoring and graphing is understanding the concept of multiplying two binomials. A binomial, do you guys all know what a binomial is? Like there's polynomial. Let me just talk about this really quickly. This is why I wasn't planning on doing this with them. I wasn't planning on saying this, but that's okay. There's polynomials, which is poly means many, nomials means number. So polynomials, it's usually one word. It's not a capital N there, so the way I wrote it. But polynomials are, it says many numbers. So a polynomial, ironically, this could be a polynomial. This could be a polynomial. This could be a polynomial. Or I could go further and further. Now, polynomials are broken down into three possibilities, or polynomial itself. But you could have a monomial. Mono means one. Monomial. Monomial, that's a monomial. There's only one term, right? Then you can have a binomial. Binomial. I can't remember if there's a dash in there or not. I don't think there is. But binomial, bi means two. So you'd have two numbers separated by a plus or a minus sign, right? So two terms. One term, two terms. And then this would be, what would this be? Trinomial, right? Because tri means three. Trinomial. Okay? And if you have anything more than three, I've heard some people say quadrinomial for four, but most people just say polynomial. Whenever it gets to be four, or five terms, or six terms, they just call it a polynomial. The weird thing to me is that a monomial is a polynomial, because poly means many, and monomial means one. But monomial is a type of a polynomial. Kind of weird, but that's the way it is. So anyways, we're going to be talking about these, binomials, and binomials multiplied times binomials. And we're going to use a process called FOIL. There's another way to do it too, but I'm going to first teach the FOIL method. And then I'll show you the other method, which is exactly the same thing, but a totally different way to look at it. But so FOIL, we first have to understand what FOIL is. F stands for first. O stands for outside. I stands for inside. Did you guys do this last year?
Yeah.
We did. Oh, good. And then L stands for last. I forgot that you'd done this. Okay, that's great. Because I didn't have you. So I'm never quite sure what you've been taught. So, but some of you haven't, actually. There's 3 at least in here that haven't learned this. So you have to understand those things. And then if I put two binomials here, in parentheses, say x plus 2 times x plus 3. Okay? So I have to figure out what is first, what's outside, what's inside, what's last. So first means the first number of this binomial, which is what?
X plus 2.
Yeah, well, the first thing in this binomial is the x.
Oh.
So this is my first, right? Right there. And this is my first on this one. So what is the first number here times the first number there? What's x times x?
2x. X squared.
X squared, right? So I would write x squared. And then the outside, think of this as like a house. And you have your outside windows, right? Your window, you have a window against this wall, and you have a window against this wall. Those are the outside walls, right? So your 2 outside numbers would be x and 3. Does that make sense? See that? So what it would be x times 3? 3x. And is it positive or negative? Positive, because there's no negatives, right? So just plus 3x. Now I got to do my inside. Think of it that this is a house again. My inside of my house. The inside walls, these are my inside walls, so it's 2 times x. 2x, right? And it's positive, so I'll put plus 2x. And my last would be the last number, right? That's my last, and that's my last. So 2 times 3 is 6, and it's positive, so I put plus 6.
Oh, I remember this.
Now, once I've done that, I notice that my I have the x squared, I have 2 inside terms that are like terms. Don't you agree with me? Right? They're like terms. They both have an x. So could I combine them?
Yeah.
Yeah, and so that's what you usually do. You want to combine those. What would that be?
6x plus 6.
Well, what's
Oh,
3x
that's
plus 2x? 5x, right? 3 x's plus 2 more x's is 5 x's, right? So I have x squared, this is my final answer, plus 5x plus 6. It's not hard, it's pretty easy.
So you
Right?
don't combine the x squared and
Now,
5x.
ironically, look at this. If I left it as a quadrinomial, or a 4-term polynomial, I could actually factor by grouping,
Yeah,
and
that's what
I would get that.
That's what
I'm
I thought.
saying? But right now, what I'm not doing factoring, I'm doing the reverse. I'm actually taking something factored and I'm multiplying it out so I get, this. If I wrote it like that, then I would probably use factoring by grouping, or I'd combine these and have it like this, right? But this is the most common acceptable way. They expect you to add these like terms in the middle. Yes,
So you don't,
that's the answer.
you don't combine 5x and x squared.
No, because those are not like terms, because that is an x
Those are
times x.
times 2.
This is just an x. Totally different,
That's
right?
just plus.
You see what I'm saying?
5x is like an x plus an x plus an x plus an x plus an
If
x.
the exponents are different, they're considered completely different variables, basically, right? It's like a z and an a, right? If they've got different exponents, you can't have them the same. They're not like terms. Okay, so let's just practice a few. Does that make sense, though? How many people remember this a little bit? Okay, awesome. And then Naima, is it making sense? Do you get it, sort of? Well, after we do a few, you'll start to see. 904, we're fine. Okay. This is not erasing. Okay, I'm going to try changing my pen again. Okay, let's try this one. How about we do x minus 4 times x plus 7. That looks scary, right? With all those weird numbers. All right, let's try it. First of each of the binomials would be x times x, which is x squared. Now my outside, 7 times x.
7x.
And it's positive, right?
7x.
So I'll have to put plus 7x. Now my inside, right here,
Minus 4x.
negative 4x or minus 4x. And then my last,
With -28.
negative 28. Now, I'm going to combine my like terms in the middle. I have 7 x's. Somebody takes 4 of them away. How many do I
It'll
have?
be x squared plus 3x minus 28.
X squared plus 3x. Does everybody agree?
Yeah.
Yeah.
Beautiful. So that's it. That's the right answer.
Does it get any harder if this is hard as we're doing this?
So yeah, so now I'll do slightly harder ones, okay? I think the homework, I can't remember with the homework whether I put slightly harder ones on here or not. Yeah, there's a few. There's a couple. But most of them are fairly simple like these. But they're all really pretty simple. The only thing that could be harder would be like this. What if I had 2x plus 5 times 3x minus 2?
Wouldn't it be 6x?
Right, so my
Squared.
first,
Oh,
it's got to be 2x times 3x. 2 times 3 is 6. X times x is x squared.
Okay, so
Right?
it'll be 6x squared.
So you can't possibly see all this.
5x?
Can you really? Awesome.
Maybe
Here,
6x
thank you.
first?
So yeah, 2 times 3 is 6. And then x times x is
Squared.
x squared. Okay. Now, what do? What's the next one?
Plus.
2x times
It'd
negative
be
2.
minus.
All right, so 2x, my outside, right? 2x times negative 2. Negative 4x, right?
Negative 4x.
Negative 4x.
Plus.
Okay, and then inside,
Plus
Plus 15x.
okay, plus 15x. Out the last,
plus minus 10.
Minus 10.
minus 10. Okay, now I've got to combine my insides.
X
It'd
squared
be, yeah,
minus
minus 6x.
19
11x. Would it be 11x?
squared.
Well,
No, because you're,
is it minus or plus?
you're taking
Minus.
14 away.
Right.
I've got 15 x's. I'm taking 4 of them away.
11.
It'd be
15 minus
Yeah.
4 would be
11x.
11, right?
Yeah.
Positive 11. Plus 11x minus 10. There's my answer.
Okay.
Make sense?
So you usually just leave the last part without the x.
Well,
Yes,
yeah,
and the last,
because
the very
you
last number usually
can't
does not
reduce
have an
it.
x. Because notice, there's nothing, well,
And it doesn't have an
the
x.
last
on it.
number has no x there. Now, I could, can I erase this?
Yeah.
I'll just show you one other, which is slightly harder. But this is now how I create these problems you've been doing for the last week. Watch. Let's say I did this. 2x to the 4th plus 3x times 4x to the 3 plus 2. Okay? Now this is not your typical, this is not like a quadratic. It's not going to be a parabola if you were trying to do it. But let's look at it. We've got 2 times 4, that's 8, right?
Is it 8x to the 7th?
8x to the 7th. And then my outside
4x to the 4th.
plus 4x to the 4th. My inside,
4.
okay, plus 12x to the 4th. And then last,
Plus 6x.
plus 6x. Okay, so now I could combine these two middle ones, right?
We have 3 that are the
But
same.
notice, this is the kind of problem I've been giving you for the last few days, where I said factor by grouping, right? This is a perfect candidate for factoring by grouping.
Oh, you can do that.
I was
Right?
wondering what
So
we
immediately you start factoring these, right? So this is how I just randomly write things like this up here, and I multiply them out, and that's what I get. And that's what happened when I did that problem that didn't work yesterday. I multiplied it out wrong, right? I did something wrong.
Yeah, I was wondering like what problem involves these like parentheses.
Yeah, yeah. But you're going to start to understand these way more as we move forward, right? But so if I was going to factor this out, what would be my greatest common factor?
4.
4, and then either x to the 7 or x to the 4th. X to the 4th, parenthesis, what would be inside?
2x.
8 divided by 4 is 2. I have 7 x's, take 4 of them away, I have 3 of them left over, right?
Yeah.
With
Yep.
me?
Mhm.
All right, plus 4 divided by 4 is a 1, x to the 4th. Okay, so I have to put a 1 there, right? Because 4x to the 4th times 1 is 4x to the 4th. And then plus, what can I take out of this? 6 and an x, right?
Yeah.
And that gives me 2x to the 3rd plus 1. Look at this, 2x to the 3rd plus 1, there's my blob, right? So I could factor that out, so my final answer was 2x to the 3rd plus 1 times 4x to the 4th plus 6. So, or plus 6x. So now you understand, I used FOIL to create these problems for you guys.
Okay.
Today, okay? So here's the homework. Let me just turn this thing off.